Alright, hello class, and welcome to today, where we're learning about impulse and momentum. There we go. Alright, so let's see if we can get this done this way. Please give me in the share stuff spot on Echo if you like getting lecture like this, or if you think it really sucks and you'd like me to figure out some other way. Alright, let's go ahead and get started. If you're in prep physics, you are taking notes on this stuff on page 53. If you're in AP, you're just taking these notes wherever you want to. Alright, so let's go ahead and get started. The idea of impulse. The idea of impulse is this. When you punch someone, it hurts. Alright? Now, if you punch someone with a short punch, called the jab, that hurts. But if you punch someone for a longer amount of time, it hurts a lot more. The idea is this. Impulse is how hard something is being pushed, for how long it is being pushed, and in what direction. So, how hard are you being pushed? That sounds a lot like force. For how long? That sounds a lot like time. The change in time. And in what direction? Well, that sounds a whole lot like plus or minus. Up, down, left, right. If you really wanted to go crazy, you could give it an angle, whatever. Alright, so that gives us our equation. Impulse is equal to force times the change in time. And this is measured in Newton seconds. Craziness. If you prefer, you can also use kilogram meters per second. Whichever one you prefer. Or you can make up some really crazy name like ducks. Don't do that. Alright, so there we go. Wait a second. If we know that impulse here is force times time, what are we saying? Well, let's check it out. We know what force is. It's mass times acceleration. So what we're saying is the more time there is, the more acceleration, the longer acceleration is accelerating. Okay, well, we know that the final velocity of something is equal to the initial velocity of something plus the acceleration times the time. So we're saying that the longer something gets pushed, the bigger the impulse, the longer it accelerates, and the longer it accelerates, the faster it goes at the end. Alright, so, for instance, you have a baseball. You have a baseball bat. Let's try that again. Baseball bat. Baseball. Alright, now, we're saying that I am going to hit this baseball with positive 500 newtons. Craziness. Now I'm going to do this for exactly 0.05 seconds. So what is its impulse? Alright, well, right off the bat, I know it's going to be positive, because that's positive. So now all I need to do is 500 times 0.05. Huh. Well, I can't do that in my head, so I'm going to pull out my handy-dandy calculator. 500 times 0.05 equals 25. But I'm not done. Now I'm done. Remember, if it doesn't have the sign, if it doesn't have the units, it's not a complete answer. Alright. Craziness. Impulse. Alright. Next on our list of stuff to learn. This idea of momentum. Now, momentum is one of the hardest things to define in physics. So I'm going to give a lame definition. I'm going to say it's how much oomph something has. So imagine throwing a baseball at someone's face. Now imagine throwing a baseball-sized piece of styrofoam at someone's face. Even if both those things are going the exact same speed, the baseball hurts more, the styrofoam hurts less. The reason is the baseball has more momentum. And it has more momentum because momentum, represented by letter P, is mass times velocity. So two things that have the same velocity but different masses have different momentums. The thing with the biggest momentum hurts more when it hits you in the face. Questions? Concerns? I just realized I can't hear you, so I can't really answer those questions or concerns. So moving on. Let's see. This is also measured in Newton seconds. I'm sensing a pattern here. Crazy. This also needs a direction. Interesting. So, alright, if I have a mass 1 kilogram ball traveling at a velocity of positive 5 meters per second, I can find its momentum. That's positive 5 Newton seconds. Yay! Now, if I have something that's half that mass, traveling at the exact same speed, velocity, sorry, its momentum is not going to be the same thing. It's going to be less than that. I don't know what I'm doing. Alright, there we go, Newton seconds. Ta-da! Alright, so, now I'm going to give you a series of problems. When I write these down, I'm going to ask you to pause the video and solve them. And when you're done solving them in your groups, you're going to start the video again. This should still, by the way, be on page 53. There should be plenty of room. This is not a whole lot of notes. Alright, so let's see. We're going to say that Mr. Saslow applies 500 newtons of force for 1/10 of a second. Assuming he pushes for 500 newtons on a block or whatever, for 0.1 seconds, what is the impulse? Alright. Step 2. Now, same story. If I'm pushing this block with positive 500 newtons for 0.1 seconds, I want to know, well, if its mass is 20 kilograms, what is its acceleration? And if its initial velocity is 0, what is its final velocity? Ooh, a two-part question there. Crazy. Wonder where I'm going with this. Alright, so, let's see. We have a completely unrelated block of mass 20 kilograms. Coincidence. It has a velocity of 0 meters per second. What is its momentum? Last step. If I have a mass of 20 kilograms, and it has a velocity of Now, if Mr. Sazzo had been smart, he would have the number written in front of him, but I don't, so, chill out. Okay, I think that worked. Hopefully I just didn't start a brand new thing. Positive 2.5 meters per second. What is its momentum? Alright, at this point, please press pause! Why haven't you pressed pause? Alright, I'm going to assume you've pressed pause and you've solved the problems, and now you're looking at me sort of confused. You're like, Mr. Saslow, that's strange. Some of these numbers are the same. Correct! The point of this entire lecture is the idea that impulse is equal to the change in momentum, which means that the force times the change in time is going to be equal to the final momentum minus the initial momentum, which means the force times the change in time is going to be equal to mv final minus mv initial. Craziness! Alright, I'm done. Go do your worksheet. It should be linked on the agenda.